Hi, you're welcome back. I'm still Simeon, and we want to get a bit further today to look more at integration. Now, now we want to see how to integrate some functions of in trig functions. So let me start with something simple. Integrate integral of trig functions. Now that's what we want to look at today. I'll try and mix everything up together, but I'm trying to create a foundation for us. Now the first one, let's imagine we are given sine x dx. Now the integral of this becomes cos x plus c. Now cos x dx is equal to sine x plus c. Sec squared x dx is equals to and x plus c. Now let's start with this fundamental trig functions. So let me see an example. Let me show you an example. We are asked to then these are the fundamental trig functions. Now the questions might not come straightforward like this, but these are the fundamentals. So we now apply what we call change of variable method. Change of variable method to trig functions to determine integrals of trig functions. Now pay attention to this. It's very crucial that you understand what I'm trying. Try to understand this. Then you now see how I'm going to be applying this change of variable method to find or determine the integral of a trig function. Now imagine we are given something like this. Sine 3x plus 7 dx. We are asked to find the integral of this. Now it's not quite straightforward, like it's not the same thing. Like I cannot say that this, I cannot just say that this is equal to minus cos 3x plus 7 plus c. This is wrong. So we cannot apply that. So we are going to use this. You see me applying this to all the same in this tutorial. This is wrong. You can see it's not equal to. So what I want us to understand now is how do we go about this, and what we're going to do is to use what we call change of variable method. Now what we assume is we will say let our u, or use any alphabet, let u be equals to 3x plus 7. Now once you've gotten you have assumed that let your u be equals to 3x plus 7, you now say that you find the derivative du dx, which is equals to 3x plus 7. That will give us 3. So we are saying that du dx equals to 3. Now, but since we are trying to change the variables to u and du, so we will now say that our dx is equals to du over 3. So we have that. So now we have to now rewrite this. We now have to rewrite this. This will now become sine u. Now instead of writing the x, we are going to write the u with 3. So that's 3. This 3 we can bring it out. That will be 1 over 3 is a constant. So sine u du. So we have that. So it is easier now because we know that our sine u du is same thing as minus cos u plus your c. Now it's much easier for us to determine this because I've given it in the table up there. Now I can now take this. I can now say that this man is same thing as 1 over 3. Let's put this minus cos u plus c. So I will now put back my u, 1 over 3. So that minus can come here, cos 3x plus 7 plus my c. So that gives us that. Now this is how to go about this. This is an application of change of variable method. We're going a bit further now. Once we are through with this, we can derive a particular formula from this. If you are asked to find sine ax plus b dx, you can say it's the same thing as 1 over a minus cos ax plus b plus our c. So this will be this for this. This is the particular formula for this. Instead of if you are in an exam or you're having a multiple choice questions, you can quickly use this instead of going through all this lengthy process. You're not asking in a multiple choice question. Nobody is expecting you to show your workings, so you can quickly apply this, and you're through. So now let's look at another one. We are given cos 5x plus 7 dx. We are asked to integrate this. This is another example. I want us to see how I'm going to do it. Another example. I want us to see how I'm going to go about it. Now, if we just follow the step, let u be equals to 5x plus 7. So we have that. So now I will have to find du dx. That gives me 5x plus 7. That gives me 5. So now then I also need to find the x and make the x equal to the formula. So my dx, so you have said that our du dx is equals to 5. So we can invariably say that our dx is equals to du over 5. So that is that. Now once we have been able to do this, the next thing is to take this particular man. So we can rewrite this. This man as cos u, because everything here is our u. We said let it be u. Imagine, let u be equals to 5x. Now, instead of writing the x, we have said our dx is equals to this. So I will now write that. So du over 5. Now, this 5 is a constant, it's an arbitral constant. So we can bring it out. 1 over 5, it doesn't disturb our workings. Cos u du. So we have that. Now, once you are almost through. Now we can integrate this. We can find the integral of this. So we can say 1 over 5. Now if you find the integral of cos u from our table written up there, from the table I've written up there. So once we have that, we can say that this is same thing as sine u plus c. So we know what our u is. We substitute it back. 5x plus 7 then plus c. So that gives us the integral. So next time, a shorter one that we can use is to say that if you are given something like cos ax plus b dx, so what you just need to do is to say 1 over a sine ax plus b plus c. So that's it. So we have that. So now the third one, because I wrote out three fundamental trig functions, fundamental integral functions. Now the third one. Now imagine we are given just the same method. So let's see an example again. We are asked to find integral of sec 2x plus 5 dx. So this is raised to the power of 2. So imagine we are given that. So what we need to do is to use the same method. So let our u be equals to 2x plus 5. So our du dx is equals to 2. That means if you take the derivative of that, now our dx is equals to du over 2. I'm sorry to blow my nose. So we have this. Now, once we are at this level, we can rewrite this. So this one becomes sec squared u du over 2. So always remember that we are substituting, we are using change of variable method. So this 2, 1 over 2, we can bring out that. So that gives us sec squared u du. It's easier to work on this now, and then we integrate. So this gives us 1 over 2. Now if you take the integral of sec squared u, it will give you tan u plus c. So we through 1 over 2 into tan 2x plus 5 plus c. So that's what we have for that. So in a nutshell, if you are given something like 2x plus 5 no this is ax plus b. So we have that dx. So if you are given something like this, it's quite easy, straightforward. So just write 1 over a tan ax plus b plus c. So we have this. So that's what we have for that. So I can bring out let's summarize all the formulas we have so far. Summarize. So we have the first one. So the first one we have sine ax plus b dx is same thing as 1 over a minus cos ax plus b plus c. Cos ax plus b dx equals to sine 1 over a ax plus b plus c. So then we have the last ax plus b dx. So we have 1 over a tan ax plus b. So these are what we have for this trig functions using change of variable method. Now we can bring out, so we have been able to bring out six formulas from this. So let me just bring this forward so that you can see better. So we have this. Okay, let me add it to this. So we have this. So once it was just sine x, cos x, sec x, and that like that. So I don't want to make this video long so that you can have good grips. So I'm going to do another video again so that you see and understand what we're talking about when we are talking about integration. So if you enjoy our video, try to subscribe and hit the notify button, that bell button there, so that you be notified when there's a new update to a new video, a new teaching. So we'll see in the next video. Thank you.